Hello everyone, I am Rakshita studying Electronics and Communication Engineering in Sri Venkateswara College of Engineering, Bangalore. Today we are going to study about a topic, Astable multivibrator. Introduction to Astable multivibrator. An Astable multivibrator is a type of electronic circuit that generates a continuous output waveform without the need for the external triggering. It is commonly used in applications such as timing circuits, pulse generation, and frequency modulation. The circuit consists of two active devices, typically transistors, that alternate between on and off states, creating a continuous oscillation. You can see the Astable multivibrator diagram on the screen. Let's move forward to the next slide, working principle. The Astable multivibrator operates on the principle of the positive feedback. When one transistor is on, it changes the timing capacitor through a resistor, while the other transistor remains off. As the capacitor changes, the voltage across it increases until it reaches the threshold voltage, causing the first transistor to turn off and the second transistor to turn on. During the process of discharging, the voltage across the capacitor C1 crosses cut-in voltage at which the transistor starts conducting. Components of the Astable multivibrator. The key components of an Astable multivibrator circuit are two transistors, resistors, capacitors, and power supply. The transistors are typically connected in a flip-flop arrangement, with one acting as an emitter follower and other as an common base amplifier. The resistors are used to control the charging and discharging of the timing capacitors. Frequency and duty cycle. The frequency of the Astable multivibrator is determined by the value of the resistors and capacitors in the circuit. Increasing the resistance or capacitance will result in a lower frequency, while decreasing them will increase the frequency. Duty cycle refers to the ratio of the time circuit spends in the on state to the total time of one complete cycle. See some of the formulas. T on equal to 0.693 into Ra plus Rb into C. T off equal to 0.693 into Rb into C. T seconds equal to 0.693 into Ra plus 2 into Rb into C. Frequency in Hertz equal to 1.44 divided by Ra plus 2 into Rb into C. D in percentage equal to Ra plus Rb by Ra plus 2 into Rb. C equal to 1.44 divided by Ra plus 2 into Rb into F. Advantages of a Astable multivibrator. The Astable multivibrator is simple and cost efficient to implement. It does not require external triggering, making it self-sustaining. It can generate wide range of frequencies and duty cycles, making it versatile for the various applications. Applications of the Astable multivibrator. Timing circuits. Astable multivibrators are commonly used in applications that require precise timing, such as clocks, timer, and frequency counters. Pulse generators. They are used to generate pulses of a specific duration and frequencies, essential in the applications like digital communication and data transmission. Frequency modulation. Astable multivibrators are employed in frequency modulation circuits where the frequency of an input signal is varied based on the output of the circuit. These are the applications of the Astable multivibrator. Let's move forward to the next slide. Oscillation control. The frequency of the Astable multivibrator can be adjusted by changing the values of the resistors and the capacitors. By selecting appropriate component values, the desired frequency and duty cycle can be achieved. The stability of the oscillation can be improved by using high quality components and proper circuit designs. Circuit variations. There are various circuit variations of the Astable multivibrator, such as transistor based circuit, 555 timer IC based circuit, and operational amplifier based circuits. These variations offer different advantages and characteristics, allowing for customization based on specific requirements. The choice of the circuit variation depend on the factors such as complexity, power requirements, and desired functionality. Let's move forward to the next slide. Circuit design considerations. When designing an astable multivibrator circuit, it is important to consider factors such as power supply, voltage, component tolerances, and temperature. The choice of the transistor and their biasing arrangement should be carefully determined to ensure proper operation. Component values should be selected based on the desired frequency and duty cycle, considering the limitations of the available components. Summary. A stable multivibrator is a self-triggered electronic circuit that generates a continuous oscillation without external triggering. It consists of two transistors, resistors, capacitors, and a power supply. The circuit can be used in various applications including timing circuits, pulse generator, and frequency modulations. Thank you for watching my video. Please do like, share, subscribe my channel.